Hello everyone and welcome to Binomial Distribution Examples number 3. We're going to go through some more questions using the binomial theorem and tables to answer them. We're also going to calculate mean and variance. So in the first question we're told that the probability of Chris selling a magazine is 0.09 and we're asked to find out the probability that he sells it to exactly 4 people if he approaches 40. So we know that x is 4, n is 40, and p is 0.09, and we can use the binomial formula to work this out because x is exactly 4. So we can put our values into the binomial formula and work out 40 choose 4 using the combinations formula, and we should get our final answer of 0.2011. In part B, if Chris sells to at most 2 people, x is less than or equal to 2, because he could make no sales, 1 sale, or 2 sales. So using our values of n and p, we can use the binomial formula to work out the probability for each of these values of x. So in each case, use the combinations formula as before to work out the first bracket, either 40 choose 0, 40 choose 1, or 40 choose 2. Then putting all of these numbers into the calculator, you should end up with 0.28942. For part C, for more than 5 people, x has to be greater than 5. So x can't be 5, but x can be 6, so it's the same as saying x is greater than or equal to 6. And as we spoke about previously, that's the same as 1 minus x is less than or equal to 5. So we need to work out the probability that x is 0, 1, 2, 3, 4 or 5. Well, we've already worked out the probability for x is equal to 0, 1 or 2 in part B, and we've already worked out the probability that x is 4 in part A. So we just need to work out the probability that x is 3 or x is 5, subtract them and the previous results from 1 to get our answer, which is 0.1465, and that is all worked out with no tables. In the next question, we're given the probability that Anna wakes up before her alarm as 0.4. We're asked to work out the mean and the variance for the next 7 mornings. So x, the number of times she wakes up before the alarm, has got a binomial distribution of 7, 0.4. So n is 7 and p is 0.4. Now the mean, which is also written as mu or e of x, is equal to n times p. And so we can work out the value for the mean to be 2.8. Now the variance, which can also be written as var x or sigma squared, is equal to np times by 1 take p. So this is also relatively straightforward to work out, and we get the value of 1.68. For part B, to wake up at most once, x is less than or equal to 1, but this is also the same as the probability that she wakes up 0 times plus the probability that she wakes up once. And we can use the binomial formula to work out exact probabilities. So if we put the correct values into the formula for x equals 0 and x equals 1, and remember to work out the first brackets using the combinations formula, 7 choose 0 and 7 choose 1, which I won't repeat here, then if you put the numbers into the calculator correctly, you should get the answer 0.15863. You could, of course, get the value for x is less than or equal to 1 from the tables if you were allowed. For the next part, to wake up in more than 1 but less than 5 mornings, x would have to be greater than 1 but less than 5. So x can't equal 1 or 5, so it's the same as saying x is greater than or equal to 2 and less than or equal to 4. Therefore, if we get the tables for n equals 7 and find the value for x is less than or equal to 4, we can subtract the value for x is less than or equal to 1 from it to get our answer, which is 0.745. And for part C, we have to work out the probability that she wakes up on exactly 7 mornings in the next 4 weeks. And we can write the binomial expression like this because now n is 28 and p remains 0.4. So to find the probability of waking up on exactly 7 mornings, we have to put x equal to 7. And because it's exactly 7 mornings, we can use the binomial formula to work it out. So putting all the numbers in correctly, and using the combinations formula to work out 28, choose 7, we should end up with the answer 0.0426. And for the last question, we're told the probability that Phil walks to work is 0.1, and we're asked to find the mean and the variance if we're using 20 days as our sample size. So we can write the binomial expression like this because n is 20 and p is 0.1. And then, as in the previous question, we explained the mean, which could also be written as mu or e of x, the expected value of x, is equal to np. So if we times 20 by 0.1, we get our answer of 2. And as before, the variance, or sigma squared, is equal to np times by 1 minus p. So if we put our values in there correctly, we should get 1.8 as our answer. Next, we want to work out the probability that Phil walked to work on exactly 2 days. So x is equal to 2. And because x is exactly 2, we can use the binomial formula to work this out. So first we put all our numbers into the binomial formula and then use the combinations formula to work out 20, choose 2. And if we've typed everything into the calculator correctly, we should end up with the answer 0.2852. For the next part, to work out the probability of walking to work on at most 3 days, x has to be less than or equal to 3. So if we locate the tables for n equals 20 and go down the 0.1 column to 3, we'll get our answer, which is 0.867. And finally, we're asked for the probability that he walks to work on more than 2 days. So x is greater than 2. And as x can't take on the value of 2, it's the same as saying x is greater than or equal to 3. And as we've mentioned previously, all the values in one column add up to 1, we can subtract x is less than or equal to 2 from 1, and that will give us our answer, 0.323. Thanks for watching. I hope you understood everything. If you haven't, it might be worth going back and looking at some of the previous videos in this series. But for now, I'm just asking you to press a thumbs up if you could. That would be great. And subscribe, and I'll see you in the next one.